Good morning, everybody, and welcome to the G2M Research and Kioxia webinar on software-enabled Flash. The title of this webinar is The Next Flash Revolution at Scale, Open Source Software plus Software-Enabled Flash. I'm going to go through kind of the agenda real quick and some of the ground rules. So, oops, one slide too much. Here we go. So, I'll introduce the topic and talk a little bit about some things, then I'll hand it over to Sean Stead. Sean is with Kioxia. He'll do the actual presentation. As a note, we are recording this webinar. Hopefully you heard the recording in progress when you signed on. We'll make a copy of this recording available to everybody a couple days after the webinar. In addition to that, we'll also provide you with a PDF of the slide set. That should go out on Thursday to everybody that registered for the webinar. And with that, the other thing is if you have questions, please use the Q&A window on Zoom. We'll answer the questions at the end of the webinar, but feel free to submit them anytime you want. We'll just sit on them, and then once we get to the end, we'll go through them. So with that, let's talk a little bit about open source software and software-enabled Flash. So as I'm sure most of you know, most hyperscalers utilize open source software in one or more of these packages in their solutions. Some of the more common ones, obviously Ceph, CloudStack, Hadoop, Lustre, OpenStack, and there's a variety of other ones that are used by people as well. Part of the reason they like using these is they can go in, they can tune them, they can customize them, they can extend them if they want. That allows them to really tailor these applications for their particular use case. And if you look at how different people use them, whether it's cloud service providers or hyperscalers, the applications they run, the use cases they have with their customers all differ. And they really have a lot of different tuning capabilities they may need to provide that. If you think of somebody like AWS, for instance, they support numbers of different customers with different use cases. So for them, being able to tune on a per application basis becomes very, very critical. And one of the things we're going to talk a little bit about today is how you could, the value of extending that tunability to the Flash media itself. Not only just speed up your application and your storage solution underneath it, but the actual hardware itself as well. So with me today, as I said earlier, is Sean Stead. Sean is a senior staff member at Kioxia. And I'm Mike Hume. I'm principal analyst at G2M. I've known Sean for a long time, and I know he's going to make this interesting for everybody. So with that, Sean, let me give you back control, and you can take it away.
Okay, great. Thanks a lot, Mike. Hey, everybody. Again, my name is Sean Stead, here from Kioxia, and welcome to our latest webinar. For those of you for the first time, welcome. I know probably a lot of you have been following this product development that we're going to be coming to market with very soon. And so we're going to get into the latest webinar on our software-enabled Flash technology. And again, this is takes all the stuff that Mike was just talking about, but it really takes it to the next level. And you'll see as we go through the presentation here that this really revolutionizes the way Flash storage is used at scale. So as we know, change in this industry is constant in the cloud and data centers. And we see all these changes happening very fast. So today's webinar, we're going to talk about a big change and a new development to help us all improve Flash storage devices. So storage, a lot of us have probably been in the industry for quite a while, and you've seen storage devices. It's basically like plumbing, hasn't really changed a lot. But basically for the past many decades, it was designed long ago. Compatibility was a priority, and that was a good thing. Storage devices today are based on the legacy hard disk drive protocols. They're basically a black box with little to no flexibility. And these legacy HDD protocol devices are really limited by this fixed interface. So, and we all know these legacy protocols, SAS, SATA, block devices, but you'll also see on this list ZNS, which has been introduced relatively recently. And you may wonder, why ZNS? It's new, but it's still based on a legacy device because the protocols are fixed, similar to these other HDD legacy protocols. and it can't easily be adapted once the hardware is installed to new changes. But you're going to find out one of the exciting things with software-enabled flash technology is you'll understand that it can support not only the ZNS protocol, but so much more, and you'll be able to modify it as you move through your applications and your various needs. So in the cloud and large-scale data centers, they face these problems that are just compounded by the HDD legacy protocols. The data placement and isolation, they need control over latency. We'll go into a little bit more on that as we go through the presentation, and more importantly, adaptability and flexibility. There's also a lot of hardware modifications, whether it's a RAID design or power loss protection schemes, or whether a DRAM, whatever DRAM size is needed. And there's complex hardware inventory management to have the different devices to accomplish all these different sets of fixed goals, again, using the HD legacy protocol. So, and these all end up being cost burdens. So you've already seen software defined as a proven benefit on many platforms, and we see that software is eating the world. There's software-defined networking. You've seen software-defined computation, other software-defined hardware. And increasingly, you're starting to see software-defined storage. But now we're going to take everything to this point. Software as defined has not really taken advantage of all that Flash has to offer. So until now, and we're going to see it's now time to apply the same logic of software defined to flash storage devices. And that's what we call software-enabled flash technology. So I just wanted to kind of stop there for a minute because, it hasn't been done. So what if flash were software defined? And what would it take? What is needed to make software defined flash? And the good news is, again, that's exactly what we're going to explore today. We're going to take the software-defined philosophy and apply it to actual flash devices specifically, not just on the software level. But today we're going to show you a new media-based host-managed approach with flash hardware. Starting with software-enabled flash technology, we're going to fundamentally redefine the host interactions with flash and allow our applications to maximize performance and provide functionality that would be difficult, if not impossible, to achieve with existing legacy HDD devices. So we're going to be giving the host control over the media that enables the host to define the behavior and performance characteristics for flash-based solutions. And this can enable a new storage functionality that maximizes the performance and efficiencies, or simply stated, it enables flash to extract the maximum value in your storage devices. So this is really an innovation that's coming to flash finally. So one hardware device and adding the software API control on top, we're bringing flash storage in line with the cloud data center needs, and finally breaking away from the old legacy HDD protocols and the fixed protocols. So yes, you can adapt and customize this flash storage hardware via the new software API host control that's being introduced with software-enabled flash technology. Change as needed by changing the drivers simply in software, all with the same software-enabled flash hardware. This is a very powerful and new way to move forward with flash, and it finally unlocks the full potential of flash. A key benefit to remember today is that with a single adaptable software-enabled flash hardware device deployed for whatever storage size is needed, instead of many different limited functionality HD legacy part numbers. So this new software-enabled flash technology API also allows existing application software code to be reused from flash generation to flash generation. So this results in faster internal development and innovation, all while improving the total cost of ownership, faster time to market with the new flash generations, And again, SKU reduction, because you can deploy the same hardware in multiple environments and multiple applications. We're going to go into more detail on that. So software-enabled Flash will have some examples of the code to help developers get started. And remember, the software-enabled Flash hardware handles all the low-level Flash details. So now we're going to move to our first audience participants survey. And what open source software storage platforms have you looked at or used? So these are some of the things that Mike had introduced at the beginning. So you can check if you've been introduced or looked at more than one, please go ahead and check that now. Then we'll have the results of this survey at the end of the presentation. Okay, hopefully everybody's had a chance to take a look at that. Thanks, Mike. So software-enabled Flash technology brings value, again, with faster time to market and adaptability. That's the key takeaway here. The software-enabled Flash hardware is modifiable through the software API. There's no need to change out the hardware when changing applications and priorities. This frees up one of your most valuable resources, the people. Those people will spend less time on mundane tasks like managing hardware inventory, and now they can focus more on actual business-related activities. This improved productivity is delivered as we redefine and improve the way Flash storage is managed, and we break free finally from these HDD protocols. With a media-based hardware approach and software-enabling API, this technology is designed to make managing Flash media easy while finally unlocking all of the amazing capabilities of Flash. First, it's an open source Flash native API. So again, we're going to go in a little bit more detail on that, but that's another key takeaway. This is an open source Flash native API. It's designed to make it easy to create Flash-based storage solutions with powerful capabilities. Software-enabled Flash technology abstracts the low-level details that are vendor and Flash generation specific so that your existing application code can take advantage of the latest Flash generations without major modifications to your applications. So you can get your applications up and running with the latest Flash media very quickly using software-enabled Flash technology. More importantly, take a look at number 4 here. Again, being an open source project, any Flash vendor, so it's not just Kioxia, is empowered to build software-enabled Flash hardware. And these devices are optimized to use their own Flash media. The software-enabled Flash project is moving from prototype to deliverables with sample code and documentation. It's starting to get published first by Kioxia, but again, this is an open source project, and we'll be releasing the complete API as an open source software development kit with reference source code, utilities, and more you'll hear about very soon. So with a foundation of open source software, and again, specific software-enabled Flash technology hardware, it's combined in standard form factors. The software-enabled Flash technology is, again, software and hardware purpose-built working together. So it's not just an open source software that's deployed with hardware you may not know is optimized for it. Again, this is the software and hardware purpose-built and optimized to be working together. These features can be optimized in software like data placement, latency control, and there's other hardware designs like whether DRAM configurations, and also enables host CPU offload. So that's freeing up CPU resources and future-proof support for the next generations of Flash with your applications. So what does the combination of software-enabled Flash, the API, and the soon-to-be-released SDK all mean at the end of the day? Time to market is faster with the right Flash generation. Also, no more frustrating attempts by data centers at designing and building hardware from scratch. As the software-enabled Flash API unlocks the full potential of Flash, and the software-enabled Flash is application-specific, but again, also modifiable as the application or priorities change within the data center. Abstraction. So a key point here also is abstracting the flash is a core function of software-enabled flash, and the software API is the key to accomplishing this. So what needs to be extracted? The low-level semantics of the flash itself, the ability to isolate hardware die for both performance and isolation. I'll show you a little bit more about that in examples coming up in today's webinar. And you can manage and modify latency outcomes depending on what your priorities are. You can offload host resources to drive efficiency of the host systems. And also lifecycle management, including garbage collection and wear leveling without any surprise IO impacts, like if your database compaction. And we'll share a little bit more of that as we're coming up in today's webinar as well. We're going to go over 3 key functions with the software-enabled flash hardware device. We'll go over multi-protocol support, the block, custom, and the aforementioned ZNS as well, and data placement and workload isolation. Also, we'll go over some legacy or latency software-enabled flash options and various queuing methods that we're going to introduce. And with these demos, I'll show you how it all works and also how you can apply it in a data center. So first off, the multiple protocols are more readily supported using a simplified supply chain of hardware. So one part number hardware device that can be deployed with as many of that same part number as needed to meet the capacity requirements. Or that one hardware device could be deployed and you just change its use case with this new software-defined for flash technology. Now I'll show you how this works in the real world as we go through. Please note these changes are all at the software driver level from the software-enabled flash technology, and no actual hardware changes are needed. So as you deploy different web applications, streaming app, database app, using either, it could be block driver, the custom software driver, and again, the ZNS software driver is needed. And you've got another block software driver running a web app expansion, maybe during a holiday rush or something like that, and you want to change out that application. You don't need to worry about changing out the hardware. You can just, as the applications change or other storage priorities arise, they can be met in real time. So with the one device, you can simply change out the application and then just change the driver and still use the same hardware that's in place. So with one type of device, you can improve the total cost of ownership in the data center by just changing the software deployment. Just redeploy the software with the software-enabled flash hardware in place as the applications and priorities change. But again, the hardware stays the same. Bring you up to speed much quicker with your applications. So now we're going to move into another idea of the isolation. So with the noisy neighbor, that's the, we've all seen or experienced noisy neighbors, right? This happens in the data center too, where resource-intensive processes can undermine the responsiveness of others on the same server or storage platform. So software-enabled flash helps solve workload isolation issues, such as the noisy neighbor problem, and helps manage the available bandwidth through application-controlled data segregation at the die and superblock stream level. At the hardware level, software-enabled flash can manage flash die isolation as a virtual device. And through software isolation, it can manage each application separately with their own namespace, protocol, and asserted security requirements. We call this our QoS domains. And now, so this one part number for the software-enabled flash storage device can be deployed with hundreds or thousands of devices, again, to meet whatever the total storage capacity requirements are of the data center. And to help understand this deployment, let's go look again at just one unit to explain software-enabled flash's capabilities. So we've isolated zones we're looking at just one device here with 32 die. And to help understand this deployment, we've isolated the work zones at the hardware and software levels. For example, 3 different drive storage protocols, the block, custom, and ZNS, as we talked about before. And well, those are physically isolated. So you can see the unused die separating in between there. And again, these workloads are physically isolated from each other. So let's take this workloads that are physically isolated, and we're going to show this in an actual, we'll show this IO demo. This is actual real software-enabled flash hardware and software running in this heat map. So using those same isolated die, you can see the reads in blue and the writes in red. And the isolation is based on the layout defined for the block mode, the custom FTL, and the ZNS modes. This animation is showing the full isolation through software down to the hardware flash die levels. It's a very unique and different device protocols are all running on the one software-enabled flash storage device. And this can be changed simply through the software device driver we showed earlier. And this can be deployed in the data center, even through the largest hyperscale platform. Okay, so now let's move to our second audience survey here. What size is your storage pool now or planned for in the future? This time we're just going to pick one. We're just curious to see what size of the storage pool in the data centers that our audience is involved with. Take a minute and pick one of those real quick. And again, both of these survey questions we'll have the answers to at the end of the presentation today. And the results will also be listed in the PDF that Mike had talked about that'll be sent out in a few days. Okay. So everybody's had a chance to click on one of those. Okay, so latencycy8. This is always a concern. Which is better, latency managed or over time? But as applications change, which one is better? It depends. Applications change, the needs change, priorities change, and so do requirements for latency and the I/O. Sometimes you need the fastest latency. Sometimes you need steady and predictable latency. But now with software-enabled flash, you don't need to always change out the hardware. From the host side, you can manage the I/O deliverables all in software with software-enabled flash's 3 unique queuing modes. You can choose the 8 FIFO command queues in a priority mode, a simple round robin, and software-enabled flash technology also introduces an advanced feature with die time weighted fair queuing, where the scheduler will actually handle the command queues for you. Again, here we're showing with real prototype hardware. It's not a simulation. Software-enabled flash can demonstrate hardware controls over latency with this simple QoS read priority slider. I can adjust the workload priorities and latency outcomes for either QoS domain 1 or 2, for example, depending on the desired outcome in each application. Where else can you so easily change the I/O loads and latency based on the running application's priorities? That's pretty incredible with software-enabled flash technology. And again, we are fundamentally changing and improving the capabilities over legacy HDD protocols. We've seen a lot of new capabilities today from software-enabled flash, but there's still so much more to software-enabled flash technology through this one device. Again, for example, high-performance flash translation layer, reusing application code to support the abstraction of flash in future generations. So let's take a look at number 7 here in this list. We know MLC, TLC, QLC, the flash media, there's future flash geometries are supported with the code reuse from your applications, so you can get your data center applications running faster with the latest flash generations and from multiple flash vendors. Again, as being its open source software protocol. Again, software flash technology is not a proprietary API. And multiple sources will be available for the API software development. And then the flash and controller hardware will be available from multiple vendors. So as an open software standard, vendors, co-travelers, and developers are free to use again, Kioxia will be kicking off this so that everybody can see the actual real world deployment. But the open source software is a neutral forum to bring this technology to the industry for the collaboration. So we'll have all of the best co-opetition, if you will. We'll have collaboration from all of the vendors creating software-enabled flash technology devices. And so Kioxia is setting up the software-enabled flash technology as a community-based open source software project through the Linux Foundation for independent access and neutral management of the standard, and encourages multiple vendors to join this Linux Foundation community project. The open source software offers collaboration from multiple vendors and is used for many software applications today and appeals to innovative developers. Now we're bringing software-enabled flash to launch through the Linux Foundation OSS community, and this helps the software-enabled flash deliver different approaches cooperatively to maximize the deliverables from multiple vendors. We're launching this in basically 3 phases. We've already launched the sample documentation on the GitHub site, and I'll have a link to that at the end of this presentation as well. And soon you will see the full public deployment and announcement of software-enabled flash technology as an open source community project with full documentation and even a complete software-enabled flash technology software development kit, or SDK. When open source software community goes public, it covers everything needed at the software level. And in addition to the OSS, there's also hardware that will be vendor specific and supported with the software-enabled flash technology for various types of flash and controllers. Again, Kioxia is going to kick this off with the open source API and full documentation. And we'll be announcing that public launch soon. So you're kind of getting an early look here. With this open source software solution, you can control the future of flash hardware devices. And with the host control software, it supports your requirements for latency control, data placement, worry leveling, and again, fast time to market with the next generation flash, all with the application code that can be used for easy and quick deployment of your applications. So as we start to wrap up today's webinar, some key items to summarize. The software-enabled flash hardware and software unlocks Flash's full potential as it sheds these legacy HDD protocols finally. Software-enabled flash delivers faster time to market with open source software control. It will be available from multiple sources and will help developers quickly unlock the full potential of flash, accelerating change through software. And software-enabled flash technology is really a force multiplier in data center economics as we fundamentally change the way flash is deployed in the data center. If you want to know more, you can check out our website at softwareenabledflash.com, where we've got the documentation there now and collateral materials, plus some other cool videos. And the Kioxia GitHub site is up now, where you can see some API examples. And finally, please, here's my email. Please let me know if you have any other questions as you review this material and think about software-enabled flash technology. And again, thank you for joining us today. And now I'll turn it over to Mike for the survey results, and then we'll also have the Q&A.
Sounds good. Thank you, Sean. Let's jump over to the Q&A part first. We had 3 questions. The first question was, you mentioned there were 8 command queues per virtual device. How many total command queues can you have for an actual SSD?
I'm not sure. It's a good question, though.
Okay. As
I
we
don't know.
can get the answer, we'll post it with the results. Then.
Yep. Yeah. So when this goes out, that's a good idea. So whatever I don't know, yeah, we'll update it before we send out. So look for the updated material.
And the second question was the changes that you can make. You can make those changes on the fly, or do you have to reboot the server?
The changes are on the fly, which actually that's a great, it's funny how when you're involved in something, it's so easy to just kind of assume everything's communicated. But yeah, that's one of the great things about just changing on the software application layer with the API not the actual hardware. So there's not the rebooting. Like normally that's the protocol requires, if you're changing hardware, of course you have to, often reboot the server or at least take it offline for some amount of time. The software itself, though, you can deploy immediately. So that keeps everything up and running.
It looks like we have an answer from Scott Stetzer on the question about the command queue. The device 8 queues for each channel. So each channel, so it's the total number of channels times 8 is the total number for the device. Thank you, Scott. Let's see. And then the third question was, are there other vendors that are yet signed up for the OSS project or are looking at it?
Well, I tell you what, everybody, you're going to find out probably around calendar Q1. Nothing's public yet, but there's definitely some very interesting announcements that'll be coming out. So nothing's public yet, but
sounds very cool. Sounds like a good New Year's present, so to speak.
Yeah, it's been a lot of years in development, and this product is actually physically coming to market in the early part of next year. So again, there's all these announcements will be made public, but I would definitely suggest everyone stay tight and keep track of Kioxia social media as well, and you'll see a lot of interesting, exciting announcements coming out when this is truly coming to market. So it's a very exciting time for the software-enabled flash technology.
Excellent. Well, thank you very much, Sean. As I said earlier at the beginning of the webinar, we'll actually be posting a PDF of the slide set and the link to the recording to everybody that registered. You should get that probably on Thursday, perhaps sooner, but depending on how quickly Zoom can turn around the recording. But so look for that in a couple days. And with that, thank you everybody who've joined the webinar for your time today. Thank you, Sean, for presenting here. I think there's a lot of great information and certainly some exciting things to look forward to at the beginning of the year.
How about the survey results?
Oh yeah, so let's go through that. So on the first poll question, let me pop that back up here real quick here. Let's see, hold on one second. So let's go to question number 1, and you guys should be able to see the results if they're not on your screen. So out of all the applications, OpenStack was number 1, Ceph was number 2, and then Hadoop and other were tied for 3 with Lustre with 4.
Yeah, it's interesting. Great, thanks.
So about 71% OpenStack. And let's see, let's go to the second question now. And the second question was, what is the size of your storage pool? Most people didn't know what the size they were dealing with, so not surprising, I guess. We have one that's less than 50 terabytes. I'm sure there's a lot of them that are significantly greater than that, but
Got it.
there you go.
Maybe not everybody wants to disclose that they're part of a huge,
Exactly.
huge petabyte. But yeah, it's interesting. So yeah, the key takeaway too on the other open source protocols, again, this with software-enabled flash technology, this is the software and the hardware combined together to really maximize the flash potential.
Yeah, I think that's the cool thing for today's webinar, that it lets you extend it yet another level beyond what people are normally used to really optimize performance for specific applications and use cases.
Yep, on the fly.
So thank you again, everybody. If you have any questions, I think Sean's info was there earlier on. Again, that'll be on the slide set as well when you get that. So feel free to ask. And again, thank you, Sean, and Kioxia for I'm going to keep saying Kioxia. So, for sponsoring this webinar. And everybody, I hope you have a great day.
Yeah. Thanks, Mike.
Thank you.